Okay, welcome back. We're going to be looking today at some more algebraic fractions, and it's going to get a little bit more complicated. And there's a reason why I've stretched this out so large. It gets a bit larger. Just don't worry about it. We'll get to it. So our first one here, we have 3x plus 3 all over 2x multiplied by x squared over x squared minus 1. Now, remember when we are doing this, it is top times top times bottom. And the first thing we want to do, though, is think about ways in which we can factor this. If we can factor it first and cancel a few common factors, our life becomes significantly easier. So we need to really think about what we can take out. And the first one, we've got to pretty much do this one part at a time. So we're just going to consider this group here first, okay? 3x plus 3. Let's factor out the 3 and be left with x plus 1. All right, we can't do anything about the 2x, so we're going to leave the 2x as it stands. Multiplied by, well, is there something we can factor out here at the top? No, so we'll just leave this as x squared. And we'll look at the bottom and we'll see that if we were to use our minds a little bit, we can see that this is a difference of squares, a super common difference of squares that you should be able to recognize really easily. And it's x minus 1 and x plus 1. Just remember the order of those two bracketed by numbers doesn't matter. Right, let's look at something we can cancel. If we're both going to be multiplying again by x plus 1, we can cancel both of these. All right, now we're left with 3x squared divided by 2x times x minus 1. And we can cancel an x here as well. So cancel one of the x's and get rid of this index. And we're left with 3 over 2 times x minus 1. 3x rather. So we're going to cancel 1. Right, so that's that done, and that's our answer, and it's pretty much what's going to happen throughout the rest of this video. We're just in for anything we can factor, and then hoping that will lead us towards an answer. All right, next one here, we have a squared plus a minus 2 all over a plus 2 times a squared minus 3a all over a squared minus 4a plus 3. And it looks complicated, but do it bit by bit and it will be okay. So first up, we have our first quadratic, okay? And if you remember, when we're doing these, we're looking for values which we can consider this 1a, which sum to 1 and that multiply, or their product, is minus 2. I'll bring up a widget for it because it's a little bit easier that way. So our first one, we needed to add to 1, the sign's important, add to 1 and multiply together to give our negative 2. Okay, so 1 will have to be, the positive value will have to be larger, right? So what's our product at 2? Well, 1 times 2 essentially, but which one is the positive and which one is the negative? Right? Which one are we going to go with? If I do 1 and then minus 2, well, I add those together and 1 plus negative 2 is negative 1, so that won't work. What if I do minus 1 plus 2? I'll add them together, they'll sum to give us 1, but they'll multiply together to give us minus 2, right? And this gives us our first essentially useful factor. So this will give us a minus 1 times a plus 2. So the first part is now done, all over a plus 2, which we can move in brackets if we would like to, and multiply it, pretend we multiplied it by 1. Right, next one. Let's look at our one up here. So this group here, what have we got? Well, we've got a common factor between them of a, so I can bring the a out the front, and I do a minus 3. And lastly, we have another quadratic. So we have another quadratic down here. And we really need to find values which are going to give us a sum of -4 and a multiply together to give us +3. So let's bring up our widget again and have a look. So we need values that we add together to give -4 and that multiply together to give a positive. So what are we thinking? We're thinking 1 times 3, basically. If I do 1 times 3, then 1 times 3 is 3, but adding them both together doesn't give us -4. If I change one of these, then our end result, -3 or +3, won't work, because 1 times -3 now is -3. But if I make them both negative, then I add them both together, and I get -1 -3, which is going to be -4, and I multiply them together, and negative times a negative is a positive. So we end up with our 2 factors here, and that's going to be -1 and -3. And we can rewrite this as a minus 1 times a minus 3. And if you multiply this out, you would still get this value here. Right? That's why we can do this. Okay, now let's look at cancelling. So we're finding any common factors. Because multiplication basically means that we essentially join all of these values together, we can cancel wherever we would like, as long as we're cancelling a numerator value and a denominator value as the same factor. So we can cancel this one, we can cancel a minus 3. If we put any others into account, we have the a plus 2 and a plus 2. And we've got a minus 1 and a minus 1. And all we're left over is a over 1, which is just a. So all of that complex operations up the top, all of that essentially just became a, which is why we want to simplify this in the first place. Okay, next one. So when we are looking at division, it's the same as when we were doing it with numerical values. We don't want the division, we want multiplication. So we're going to use keep and then change and then flip. So we're going to rewrite this as c squared plus 5c plus 6 all over c squared minus 16. And then I'll change this to multiplication. So we've kept the first fraction, changed the division to multiplication, and we're going to flip or take the reciprocal of the second fraction. And now we have everything as multiplication, and we're looking for opportunities to factor. Now our first one here is a quadratic, which should tell us that we are probably going to factor that. And we've got 2 values that will multiply together to give 6 and add together to give 5, which is probably going to be 3 and 2. And then we have our difference of squares here that we're going to look at, and then we are going to be mostly done. All right, so let's get started on our quadratic. So we want numbers that multiply together to give 6 and that add together to give 5. Right? 3 and 2 are probably our easiest candidates. Multiply them together, we get 6. Add them together, we get 5. And you can see that eventually you do get a little bit quicker doing this. So this becomes c plus 3 times c plus 2 all over, well, we've got difference of squares here, so c plus 4 times c minus 4. Right, take the square root of c, you get c, take the square root of 16, you get 4. Right, multiplied by, all right, multiplied by c minus 4 all over c plus 3. Right, now we can start cancelling. So we're going to cancel the c plus 3 and we're going to get rid of it. We're going to cancel the c minus 4 and get rid of it. And we're left with c plus 2 all over c plus. And that's our answer. Okay, now let's make them a little bit more long and irritating. In fact, this is probably one of our last ones. So we can expand this idea all the way out. And all we have to do here is remember we do not want multiplication. We do not want division. We want multiplication. X minus 8. Put back to pencil. And we want to change something here. We don't like this divide. So let's not redo the divide. And let's make sure we're back on pencil because the only pen that I have that looks good. So we're going to change that to multiply and we're going to have x squared plus 5x all over x plus 1. I think at this point we're probably getting the main idea. So this might be our last one just for time's sake. Right, let's start looking at this and see what we can find. We've got a triangle here. We've got a quadratic here. We've got a difference of squares here. We've got another quadratic trinomial and another one here, and we have a general one which we'll factor out one particular common factor. So let's get started. It's going to take a little bit of time. So we need to think about our factors here for our two different quadratics. The first one here. So we're going to add up. They have to add up to -1, and they have to multiply together to give -20. Whenever we see this, the only circumstance in which we get a negative value is if we're multiplying different sides. That means one's positive, one's negative. And in this term here, because it's negative, we have to make sure that the larger value is going to be the -1. All right, and let's think about values. Let's bring up our widget. Let's have a look. Okay, so adds to -1, multiplies to -20. One has to be positive, one has to be negative. The -1 is going to be larger. Right, what's our values or our factors or our multiples that are going to produce 20? Well, it's 20 times 1, 10 times 2, 5 times 4. 5 times 4 sounds great. That sounds really good. But we have to think about which one of these is going to be negative. And it's going to be the larger one. It has to be the larger one. The reason why is when I sum them, you're going to get -1. -5 plus 4 is -1. -5 times 4 is going to be -20. So we have to start thinking logically about which one we assign to. So this becomes x minus 5 times x plus 4. All right. This one here, we have a value squared minus another value squared. It's going to be difference of squares. So x plus 5 times x minus 5. All right, multiply that across. We have our next quadratic here. So we need values that sum together. We add them together to give -1, and they multiply together to give -2. Now you should be able to do this one in your head because we have 2, well, 1 times -2 will give us -2, and then our other value, 1 plus -2, gives us our -1. I suppose we can have a look at it. All right, next one here. So we know they both have to be different signs because they have to multiply -2. Okay, what's our products? It's going to be one's going to be 1, one's going to be 2. 1 times 2 is our only option. Which one's going to be negative? If we need it to add to a negative number, then one of them has to be negative. It has to be the larger one. 1 plus minus 2 is going to be negative 1. 1 times negative 2 is going to be negative 2. Yeah. Right, so now we can just rewrite this as x minus 2 times x plus 1. All right. That one's done, and then we have another one to look at. It has to add up to positive 2, and has to multiply to negative 8. Okay, so start thinking again. It's got to be different signs here for the multiply to equal a negative number. So what equals, or what two numbers multiply to give negative 8, or to give 8? We have 4 and we have 2. We have 8 and we have 1. 4 and 2 sounds really good. I like 4 and 2. 4 and 2. Okay. If I need to assign a negative sign to something, and I want the first product to the positive number to be larger, then we have to give this the negative 2. Right? 4 plus negative 2 is equal to 2. 4 times negative 2 is negative 8. So it's going to be positive 4 and minus 2. Positive 4 and minus 2. All right, last one. X and 5x, just factor out the common factor, and x plus 5, and then it's all over x plus 1. Now, let's start cancelling as many things as we've got. So, we've got our x plus 1. Let's get rid of that with this. X plus 5. Do we have x plus 5? We do. We have an x plus 5 here. An x minus 5 we can get rid of. An x plus 4 we can get rid of. And an x minus 2 we can get rid of. And we're left with x. We can get that as 1 times this x over 1, which is just x. Alright. A lot of work to get to that one. In fact, a lot of these questions that we end up doing like this always end up being the simplest value that you could have gotten to. Right, I think that's where we're going to call it today. So hopefully this is helpful, and I will see you in the next one.